14th, Pi Day. Okay, so Pi Day. Kathy, I have reconsidered. And for BC only, for Pi Day, we do need to keep going because we are behind. However, that doesn't mean that we can't keep going with fun, enjoyable snackage along the way that is celebrating the spirit of pi, aka circles or triangles. Yeah, last class they were like, well, triangles have to do with trig and trig has pi. And I was like, okay, sure. They wanted to bring Doritos or something. I don't know. Anyway, I know. Anyway, 3.14 extra points in your test quiz category. If you want it in a homework category, you just need to tell me when you donate it tomorrow. Okay, when you guys come in, I am guessing, just based on past years, my table that will be in the front of the room and will probably have quite the spread of leftovers. You guys, however, if you want to bring in your things and not leave them in your lockers, etc., like last year, there will be papers posted up at the tables, so you can put your contributions in here before school, but don't put it on the table or else it will get eaten before we come to your class. So put it under the table in your period and we will not touch it, hopefully. But when you come in, don't go straight for the food, please. We'll treat it differently than like donut holes and coffee. So don't go straight for the food, go straight to your desk, so whatever we do need to accomplish, we can at least start. And then we can time out, and then you guys can go up and grab what you have to contribute, and then I can mark down what you have in the appropriate category that you want it to go. And then you can put it on the table, and then we'll just keep on having fun. At the end of this class, if whatever you brought has not been eaten and you want to save it for friends for lunch to continue the Pi Day celebration in your own way with your own peeps, you just need to pull it off the table. Yeah? Pull it off the table, put it back underneath in your period, or put it up here in the drawers, not the nursery drawers, the drawers that are empty, not all over Janelle's blanket. But anyway, if you don't want yours to keep going and be contributed to period 6 and their celebration, you just need to pull it off and put it under at the end of class. But it does need to be something circular, something store-bought, restaurant prepared, unless you talk to me otherwise, and able to be shared. Now, hold on. Last year, I had some people like, oh, we didn't think about it, and run over to Snack Shack and grab like a little thing of Oreos and put it on the table. And I was like, then I had them getting like multiple, and then let's just something that can be shared for more than just you. If you come with a donut, I'll say, yay, have fun with your donut, but no extra credit. But if you come with, you know, like a dozen donuts or like a box of donut holes or like some, I was going to say bagel bites, but that's technically not. If you bring like a box of bagel bites and go to Richmond's and heat them up and then bring them over, there you go. Although he's not here. That is a little bit on the edge of store-bought, but it's still kind of the idea. If you have Pieology, deliver pizza pies from Uber Eats. That, you know, there you go. But anyway, what? Ponder what you guys want to bring. I would suggest not just sweet, also savory maybe. And then if drinks have a cylindrical shape or maybe even a box, I don't know how I would justify that though. Drinks will be nice, and I'll try to have coffee if it's still here after 3 periods. I have no idea. I can only do what I can do. But there you go. Yeah.
If you have like a pie that needs to be like refrigerated, can we use yours if you want us to make it?
I don't know how to answer that question.
I mean, we have.
If you can store it in Richmond's, that'd probably be smarter, at least for you guys, because I'm sure others with cream pies and whatnot.
Okay.
Yeah. Good question, though. Other details that need to be covered as far as extra credit, what you can bring, when you can bring it, what it can count towards. We're good? The room or the chairs?
And we have in the middle, we have like a circular thing with all the food on it.
Oh, that would be so cool.
And then you go and
But I don't
over
have a
the
circular thing. I mean, that'd be really cool, but I don't know.
We can make one. Mr. Horn?
Period 1, you're in the first quadrant. Period 2, you're in that.
Wait, that'd be kind of funny.
That would be kind of funny, but I'm just not that cool.
And then it's like pi over 6 go, pi over 3 go.
I feel like Mrs. McCrae would do this if we gave her the idea, but she would need a while to do it. She wants to like paint number lines and like fractions on the steps up to the library and like have like a protractor like as her door opens and paint it on the ground. Yeah, she's cool like that. All right, cool kids. I'm not that cool of a teacher. Ratio test. Let's go ahead and get back into CalcBC in section 10.4. And we need to do as many examples as possible because it's not that hard. It's just taking us forever to get here. Because of 10.3 Lagrange questions. I get it, I do, but don't worry, we have practice tests and practice FRQs. We'll practice putting it all together once we finish the content. Maggie, go ahead.
Okay, I have a question.
Yeah.
So we got 2 packets. What are those 2? And then the second question is, what are they?
Okay. That's actually a good question. Right now, we have this week been finishing section 10.4 and 10.5. I think we can finish the core ideas of it today so that homework can be due tomorrow. Tomorrow, I think we'll be working on after homework questions, which I don't think will take us too long. We're going to start working on the AP packet. Now, you guys do have 2 different AP packets. You have FRQs and you have multiple choice. I don't think you have review in the book. Do you have review in the book? I don't think you do. What?
The test is on Monday?
I know your tricks. The test is on Tuesday. Sorry, I bumped it so that some of these deadlines might get bumped a little bit. Why are we so excited? No clue. Yes. Test is Tuesday, and we'll figure out the due dates for these things. But our goal, let's keep it short-sighted, although I understand we do need to kind of be long-sighted as well. But short-sighted, we need to finish 10.4, 10.5, as many examples as possible so that homework can be due tomorrow. Sound good? And then we'll figure out the packets. I'm giving you guys, I think, 2 full work days-ish for us to work on FRQ questions, multiple choice questions, one on one day, one on the other. Sound good? I say she be working as much now as she can to not fall behind, but not yet. No. But I mean, like by next Tuesday, right? To be working as much as she can as far as being as least behind as possible. But I'll work with her as far as where she's at so that she takes it when she's ready. Yeah, does that make sense? So the ratio test, before we get into section 10.4, 10.5, even though it totally applies to 10.4, 10.5, the ratio test, when can you make, that's just making it worse. When can you make a conclusion? When you take the limit as n goes to infinity of the n plus first over the nth of any sequence. If L is less than 1, the conclusion is the series converges. If L is greater than 1, the series diverges. So wait a minute. If we're trying to find an interval of convergence, and we're finding x values that will make the series, the power series, convergent, we're specifically looking at less than 1. But what's the dilemma at 1? Okay, so if we're building this off of the ratio test, which we basically are, or others before us have, and we're using their results. We are building this off of the ratio test. We're going to know convergence if we can make the limit less than 1, if we can make the x values make the limit less than 1. But the dilemma is at 1, we will know nothing. So at 1, we're going to have to do something that's called testing the endpoints. Because the endpoints of whatever interval that we find that would make the limit less than 1, that would make the series converge, the endpoints, we know nothing until we test them as to whether to make them or equal to or not or equal to, brackets or parentheses. And we will see that as we go through examples. Go ahead, Maggie, what's up? No, that's exactly what we're going to do. But we can't say with the ratio test what's happening.
But this is to find the interval of convergence.
Ratio test will help us find the interval of convergence that will make the limit less than 1. And then we're going to have to, after finding the interval, say, okay, now we have these A's and B's, these endpoints, what's going on at them? Because we only know absolute convergence between them.
And there's no error with these intervals of convergence, or there is? Like, would they, like, hit us with
The infinite series will have no error, but any truncated polynomial, even though it will be close, will have error. Does that make sense?
Yeah.
Okay, within the intervals of convergence. Okay, so we have a power series, and the power series is a series, and any series can be shown to be convergent with with the ratio test as long as the limit of the n plus first over the nth is less than 1. Wait, why are there x's? Pause. Ratio test. Doesn't it just talk about the n plus first term over the nth term? Did we have x's way back when we first learned this? No, but look at our series. Don't we have an n plus first term over an nth term, which will include the x's? Does that make sense? So hold on, wait a minute. Can you guys tell that this is specifically talking about Maclaurin's? Why Maclaurin's? What's not here? Okay, so it could be x minus c to the n plus 1 over x minus c, right? It just depends on where it's centered. So this is in general for Maclaurin. If we need to, we'll have an x minus c instead. Does that make sense? Okay, but I need you guys to put into your Endeavor card that we must test the endpoint. Endeavor number, I know, I haven't updated online. We'll figure it out. P.S. We do need an Endeavor quiz. It will be Monday with our test being Tuesday, but it will be fill in the blank like Chapter 9 OT. Sound good? But I'll update the Endeavors, and that way we'll have it all nice by Friday, maybe tomorrow. Oh, it is? Well, see, I have that special Maclaurin Taylor series. That's why I'm a little bit, because I skipped a card back here. Which isn't that different from the Taylor and the Maclaurin polynomial. What's different? The polynomial is an approximate to the function, and these are an equals to a function because what are they not? Cut off. So I'm debating life. Does that make sense? So let me debate life, let me update your Endeavors, and then let me fill in the numbers. So don't put this one in yet. Is that cool? All right. So what if we have the, there we go. Direction, find the nth term for the power series, f of x equals e to the x, then find, okay, hold on, pause. This first part is like major review from section 10.2, true? So who is e to the x? Just think about him, Wait, a way of studying, because you need to study him. Isn't e to the x, his derivative is the same thing every time? And if it's centered at 0, doesn't say to center anywhere else, then e to the 0 every time is 1. So isn't it just 1 plus 1x squared over 2 factorial plus 1x cubed over 3 factorial? Is that good? And then we have x to the nth over n factorial, and then it keeps going. Okay, so find the nth term. Oh, there he is. Then find the radius and interval of convergence for the representative power series. Well, couldn't we take a limit? Now, this is where we're going to see what this whole formula means as far as the interval of convergence using the ratio test to find it. Do we even need to worry about negatives? No, there's not even an alternator, no big deal. Let's just go for it. So we have x to the m plus 1 all over m plus 1 factorial times, you guys good with the ratio test, m plus first times the reciprocal of the nth? Now, it's been a while. Right? But remember, we need to simplify stuff. But hold on, pause. Why am I doing less than 1? Because I am specifically, remember, x's right now, they can stand for any value, and I'm just trying to figure out, okay, now I know, on our Endeavor card, didn't we write for all real numbers for e to the x? Okay, so we already know the answer. But let's see how the ratio test shows us that answer as far as when this works. Because some, like sine and cosine, only work for a certain interval. So how do we see that? We simplify. Remember, m plus 1 is the same thing as x times, right? Remember, m plus 1 factorial is just n factorial times m plus 1, right? I'm making it less than 1 because I'm allowed to, with certain x values, make it convergent. That's the point. My x to the n's reduce, my n factorials reduce, and I end up with pause. Do you have absolute values? You do, right? I just didn't put them in. Sorry. Okay, check it. This isn't so much for this example, but ones in the future. Couldn't I do x over less than 1 greater than negative 1 if I'm talking about absolute value? Kind of like think geoseries when we were doing interval of convergence with R, right? In between 1 and negative 1. Not or equal to, because once again, remember, equal to, we're in trouble. Can't I technically, wait a minute, I'm taking the limit as n goes to infinity. Couldn't I technically rewrite this as x times the limit as n goes to infinity of 1 over n plus 1. Because is x a part of my expression that needs to approach infinity? So I'm literally taking the limit of this inside piece, and as Aryan already said, what's the limit of this inside piece regardless of x, dependent on n? 1 over n plus 1 is going to approach 0. But wait a minute, 0 times x is 0. 0 is always in between 1 and negative 1, so what's true for all x values? I don't care who he is. It will always work. Therefore, what is our interval of convergence? Well, since 0 is always in between 1 and negative 1, I can therefore say there is no restriction on x. This power series, e to the x, equaling the infinite series, not a truncated polynomial that's only so many terms where there will be some error. But the infinite series is going to converge to e to the x for all values. Okay, yeah, but we're starting with the basic one. Yeah. But hold on. If the interval of convergence is all real numbers, from negative infinity to infinity, what would my radius of convergence be? Yeah, the radius is from the center, which we're centered at 0. From the center, how far can you go out and have it still be working? Infinity. But wait a minute, but it's negative infinity to infinity. Half of that is still infinite. So yeah, the radius of convergence is... I don't like that statement, but it's all right. We'll take it. All right, go ahead. Yes.
So back when you had it before the x over n plus 1, could you substitute n plus 1 for infinity? I'm talking about for the interval of convergence. Would that have been illegal? If you did x over n plus 1, substitute for infinity, because the limit is x over infinity is less than x is less than negative.
No, that would have been legal. I mean, I don't, as far as putting the infinity in, like a value, I don't think you could technically rewrite the statement with the infinity plugged in and the limit out. That would technically be a bit fuzzy in the math. Does that make sense?
And my other question was, for the x to the n over n factorial, I've always wondered this, like, how does that work with 0? Because x to the n over 0 factorial.
But remember, 0 factorial is defined to be 1. So, it got nicer. Well, okay, it didn't get nicer, but e to the x we already knew if you memorized your special Maclaurens. So what about these guys? I want you guys to set up your formulas, the limit as n goes to infinity of the n plus first over the nth. Wait a minute, but hold on. Who is this a formula of? Well, you're trying to describe it. I'm just saying, like, whatever is inside a summation notation, who is this? No. If we need to take the limit as n goes to infinity of the n plus first over the nth, set it less than 1 to make sure it's convergent. Isn't this the nth? Don't you put a sub n into a series or into summation? So this is the nth. If you were to write out the terms, then do plus ... you don't have to find the nth term if they give you a series. That is the nth term. You just need to make the n plus first term, right? Maybe I'll work through with you the first one, and I'll let you guys try the next one. So, limit as n goes to infinity of the n plus first. Isn't that going to be negative 1 to the n plus 2, right? Yeah. I wasn't going to do that quite yet, but yeah. You guys with Aryan in the sense that we're just going to cross out the alternator because of the absolute value. Wait a minute. Didn't I just find the n plus first? What am I taking the limit of? The n plus first over the nth, aka times the reciprocal of the nth. Are we okay? And we're making it less than 1 because we need that absolute convergence. Now we simplify as much as possible to make our lives better. And not just that, I'm also going to pull out any x terms because the x terms I don't really need to worry about as far as my, maybe I'll do that next. Might be a little too much fun. Double check. The x minus 5 to the n canceled out. There was another x minus 5. The 2 to the n canceled out, but there was another 2 on the bottom. And then the n over n plus 1 doesn't cancel out. So now what? If it helps, yeah, we can technically pull out the x minus 5 and just have the limit as n goes to infinity of n over 2n plus 1. Does that make sense? Remember, the limit as n goes to infinity, n is my variable, x is not, which is why I'm able just to disregard. As you guys look at the limit, hopefully it's pretty obvious. Degrees are tied. You see a 1/2, right? So we end up with 1/2 times x minus 5 being between 1 and negative 1 for the ratio test interval of absolute convergence. So now can't we solve? So we have negative 2 to 2, x minus 5, and then we have x is going to be in between 7 and 3. But why? Oh, why? Am I going to do some of this? And way down here, I'm going to say x is within 3, 7, and I'm not putting any parentheses or brackets. Wait, but we didn't do that in the last example. The last example was so easy. The last example was just negative and... Oh, we would never close that anyway. Let's not do that. So now what? We have to test. Literally, I want you to write it. Every time you write an interval of convergence. Remember how we do KG for keep going and LH for L'Hopital's? Although we kind of did the whole equals thing wrong last year. Anyway. It's okay. Keeps me humble. I want you to actually write test endpoints because in FRQs, they need to see that you're testing the endpoints. And it reminds you, every time you get an interval of convergence from the ratio test, you are not done until you check at x equals 3 and at x equals 7. The ratio test does not guarantee anything about at 3 or at 7. Wait, at 3 or at 7? What's the big deal with 3 or 7? If you plug in 3 or 7, the limit equals 1. We know nothing according to the ratio test. So when I brought up the ratio test and the less than 1, the greater than 1, the equal to 1, it's inconclusive. And if you plug in these two from the very beginning, you will end up equaling 1 with your limit. It's inconclusive, so we're not done yet. But, guys, don't we have a series? Don't we have 9 different convergence and divergence tests that we can use if we need to? So what happens if you plug in 3? Well, if you plug in 3, 3 minus 5 is a negative 2 to the n, true? So here we go. Plugging in 3. We are testing the convergence of the series n equals, oh crud, was it a 0 or a 1? Who wrote it down? 1, thanks Hannah. 1 to infinity of negative 1 to the n plus 1 times negative 2 to the n, all over n times 2 to the n. Did I write that right? Okay. Whenever there are endpoints. Now, if it's all real numbers, there are no endpoints, so then it's like, oh, just infinity to infinity, negative infinity to infinity. So, I don't remember. But, hold on. The bigger question is, do you know what to do? Yeah? Why don't we split up that negative 1 and that 2? Because wouldn't that make life a lot easier? This negative 1 and this 2, right? Couldn't we rewrite this to be negative 1 to the n and then 2 to the n? So then couldn't we rewrite this to be, hold on, so we have negative 1 to the 2n plus 1, right? Because remember, like bases we add, so n plus n is 2n plus 1, and then we have a 2 to the n, but what happens to the 2 to the n's? Nice. The question we need to ask ourselves, is this still alternating after what we just did? Because if we plug in 1, it's odd. If we plug in 2, it's odd. If we plug in 3, it's odd. If we plug in 4, it's odd. If we plug in 5, it's odd. It's not alternating. But wait, doesn't it look like it's alternating? Got to be careful. Got to be careful. So wait, if it's not alternating, couldn't we technically pull out a negative in front? It's a series. It's all added. If they're all minuses, can't we just pull out the negative? We have 1 over n, and what happens to 1 over n? Simple harmonic, p series, we can say it diverges by p series. Oh, but hold on. If you see negatives, we have to get them in one place, or else we don't know if it's truly alternating. You can't see a negative and assume alternating. You have to check it and double check. 2n is always even. Any even plus an odd is always odd. Pause. What does that mean? Yeah. So I can say at x equals 3, nope, x can't equal 3, right? Because we are looking for the interval of convergence and it diverges at 3. So what's different with 7? Someone help me out with the original series. The original series, it's 5 minus x or x minus 5? Okay. So but careful, in this one, if we plug in x minus 5, 7 minus 5 is a positive 2 to the n. True? And if it's a positive 2 to the n, can't I just... And then, is this alternating? Plug in 1, it's even. Plug in 2, it's odd. Plug in 3, yeah. I need a 2n in order to have it actually be jumping. So therefore, if this is alternating, well, don't we know this already, guys? This is going to converge conditionally, but it doesn't matter. It's convergent because of the alternator. So I can say it converges by the alternating. And you guys could go through. The limit is 0. The terms are decreasing. Good. But what does that mean? That's a yes. The other one's a no. So how do I finish off my problem? I say, well, that's great and all. 3 and 7. I mean, that was the majority of the answer, but I need the parenthesis and the bracket. Dun, 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 dun. Wait! Radius of convergence. Just go halvesies. What's the distance between 3 and 7? 4. And the radius is going to be 1/2 of that 4. Yes, which is 2, but I'm sticking it to the man to prove a point. Maggie. At, no, yes. Just brief. Show that you have understanding, comprehension of not only why convergent, not only convergent or divergent, but why. But otherwise, as long as you show like a basic understanding of why convergent, divergent, you're good. Yeah. Technically, you don't need to write the 2 words test endpoints. However, for my purposes, I want you to write it and write it and write it and write it, because what do I see BC kids mess up on when they take the mock AP? Testing the endpoints. Yeah. So, now, do you have an idea of what we're doing? So start. This one's a little, oh, it's easier. It's easier. Look at him go. It's easier. It's easier. Look at him go. Oh, come on. There's no -1 to the n plus 1. Or x minus 5. So just Issa and Daniel are not. Okay. Oh, not Issa, Deba. Wow, Issa, I looked up and I saw you. I saw you and then... I know Issa's here. Poor kid. So I've been holding on to something for quite a while. Since we're going to have to go back to convergence and divergence tests, you might want to see how you did. But corrections won't be due until after our next test. Do you want Deba's too? Naomi. Issa. On what? Hold on, wait, now I need to see. I would have never seen that, but now that I'm like, oh yeah, it does look like that. I was having a heart attack back there. Like, what? Carrie. Maggie. Eric. Justin. Sally. As you guys are looking at this, you can tell it was quite a fun one to grade. Not really. The first pages, some of us didn't like the n factorials and trying to figure that out. It was a plug and chug experimental, but the trickiest one to grade was this one, because I had to go find your parting C. P-A-R-R, ratio and root. T, I crossed out. If you guys look at the top, I think I put for everyone parting C, right? P-A-R-R-T-I-N-G-C-C, because we had direct comparison, limit comparison. So if there were any of those missing, a unique problem for each, like I said, you only needed to do 9. 9? P-A-R-R. We didn't do T-I-N-G-C-C. Yeah. If you didn't do 9 different problems, each showing in some way, shape, or form, or established, or for each of the tests. Sadly, some of you guys weren't listening to all of my hints about how the test was going to go. We did have one person solve every single one and do it basically correctly, which was impressive. But I had to take off points based on each of the tests. So some of you guys, for instance, might have lost like a whole chunk because you were missing 2 tests. And I'm like, ugh, it's horrible, but if you didn't do 2 of the tests, if you didn't have a unique problem, you missed 2 whole problems. They were 7 points each on the back. I think it was 2 points for using the test, 2 points for the correct conclusion in the test, and then the middle 3 points were for how you justified and whether or not it was right. So hopefully most of you in that just missed points here and there for either using the test wrong or something being wrong in the justification or something being wrong in the conclusion. But if you guys missed like 7 or 14 or 21 points back there, it's because I was missing a whole test or 2 or 3, and I tried to write it out so you would understand. But anyway, everything else was partial credit as far as like numbers 1 through 7. I tried to give partial credit, especially on 1 through 3, etc. But you guys can ask me about those scores a little bit later because I want to do this example. But feel free to ask me if you have any questions about grading. As always, I don't want you like blind faith it, but okay, what'd you guys do? Ratio. Okay. The limit as n goes to infinity of... Now this one's kind of awkward just because of like the nature of... But you guys could still simplify, right? We're doing the less than 1 because we're making it convergent. So you guys notice there was an x ended up, right? Wait a minute, so all the n's canceled out? So what's the limit as n goes to infinity of a constant? Yeah, it's just itself. So it's awkward because the n's are all gone, but you literally just get x over 3 is less than, oh, hey! Did you guys hear Maggie say this was a geometric and she and Ariane were debating it? This was a geometric. What did you actually not have to use? The ratio test. Couldn't you just say that r was x over 3 and make r less than, absolute value of r less than 1? Well, we're trying to find the constants x. It is a constant because n is our variable. What? But we've been doing that since section 10.1 where we were talking about geoseries and r was equal to x and we were setting r, right, in between 1 and negative 1. So we were setting x in between 1 and negative 1. We're doing the same thing here, but your r is x over 3 and your x over 3 is in between negative 1 and 1. Wait, do we have to test the endpoints then? No, because geotest, right, says in between negative 1, not including. So because of geoseries, we can actually skip the whole testing the endpoints. But what would happen if you had tested them? Both divergent. We'll see that. Just to be nice. X is in between negative 3 and 3. To follow the procedure, if you didn't realize this was a geoseries whose common ratio always has to be in between 1 and negative 1, not including, you would have gone ahead and you would have tested the endpoints. At x equals negative 3 and x equals 3. I'm going to zoom in so we can see that. We're trying to ultimately find the answer of, awkward, there we go. X is within negative 3 to 3, figuring out parentheses or brackets. Okay, as we zoom in, what happens if we plug in 3? 3 over 3. What happens when we plug in negative 3? Negative 3 over 3. Wait a minute, doesn't the 1 just get us the sum from n equals 1 to infinity of negative 1 to the n? And the other one just gives us the sum from 1 to infinity of 1 to the n? What's negative 1 plus negative 1 plus negative 1 plus negative 1 plus negative 1? The limit's not 0. Divergence test. It diverges. The limit as n goes to infinity of negative 1 to the n is not 0. And what's the limit of 1 to the n? Not 0. But 1 plus 1 plus 1 plus 1, the sum is going to infinity. And negative 1 plus negative 1 plus negative 1 is going to negative infinity. Either way, the endpoints are divergent, which means my final answer, even the geoseries would have said just between 1 and negative 1 up above, not including. That could have been a shortcut, but we could also test and say, oh, yeah. Well, but we were practicing. It was a little mean for me to give you a geoseries 1 as your first practice problem. That's fine. Thanks. Those notes are nasty, but we'll just keep going. Huh? Oh, what's the radius of convergence? Lo siento, I forgot. Yep. You guys are okay with the radius? It's on the card on the page before, but it's going to be endpoint minus endpoint is the distance between the endpoints cut in half. So how far can you go out from the center of convergence, which I think on that one was once again 0, just looking at it. You can go 3 this way and 3 that way, and that's the interval as you add more and more and more terms. That will get closer and closer, but outside those, at those, it will diverge away from the curve that you're trying to find. Whew! Let me see what, oh, hey, guys, look. For once, we're doing all right. Okay, so now let me have you go play, because this one's not geo. This one's not centered at 0, but when you get your interval of convergence, if it's like a finite interval, you'll see it branching out from 3. Does that make sense? Yeah, but you get to follow the same exact procedure as far as in the formula in your yellow card, it's based on like an x to the n, etc. But it's no big deal because you're being given a series, so you're working with what you have, and it's either centered at 0 right here or centered somewhere else. You're like, whatever. N plus first over the n. Yes. But keep writing absolute value because it does determine how you do your interval down below with the plus or minus 1. Yeah. pause, work, and I'll prepare an answer to that. I want to show you a couple things in the book. You guys do an n plus first over the nth, right? Okay. Okay. Not going to take a lot of time, but just really quickly because you guys should have the key information down. Oh, it never froze the screen anyway. Sorry. In this example or this problem, question from the homework exercises you guys had from 10.3, Part A and Part B brought up the importance of the power series. Because this differential equation is impossible to solve by hand. This differential equation is impossible to solve by hand. If you make u, and then if you try to do du, and then if you try to do it, it's not possible with integration by parts. It's not possible with, can you find a formula? If you guys were to research this differential equation, it's impossible to integrate by hand. But we've talked about how differential equations, there are whole college classes on them, applied math that's completely dependent upon them. Do you think it's important to be able to get some sort of representation of the solution to this differential equation, even if it can't be anti-derived by hand? Yes. Even though we can't anti-derive this function by hand, we can represent this as a power series and integrate that power series, whatever. It's a polynomial. I can anti-derive any polynomial and get a power series for the solution, even though I can't state it as a function. Now, that's the purpose of a power series, but there are different types of power series. There are power series that converge as you include more and more and more terms. We know sine is all real numbers if you were just to memorize a special Maclaurin, or if you were to do the ratio test, it's for all real numbers. The radius of convergence is infinity. So from 0, as you add in more terms and more terms and more terms and more terms, the power series will continue to converge to the sine curve for forever. So the infinite power series is equal to sine of x for all values of x. Now, if you do a polynomial, if you truncate it, well, then it's going to have some error. But the infinite series will equal for all values of x. Interval of convergence is important because we know, okay, we can just use the infinite power series. Now, if you're approximating, you might want to go centered towards whatever you're approximating at. But the infinite power series will converge for all. But then if you look at something like 1 plus x squared, which we know is a geoseries with a common ratio of negative x squared, you could build this power series pretty quickly with times negative x squared times negative x squared. This is 1 over 1 plus x squared. However, when you do 1 minus x squared plus x fourth minus x to the sixth, as you keep on building, if you guys notice, it looks really good and it's getting better and better and better, but only for a certain interval. Is it going to ever mimic over here or over here? Not without us moving it. So it's important to know the interval of convergence because it's going to be an excellent, like approaching, converging to, the infinite sum converging to, but only on a certain interval. So we have to know that because if we need to go somewhere else, this isn't going to cut it. Does that make sense? Shoop, shoop. And the radius of convergence is the idea of how far out can we go, and it's still going to be a good approximation if you're using it to approximate. Oh, I'm back there, and I don't mean to be back there. Let's go back to our notes. So you guys were playing around with these two. You guys notice this is the end of section 10.4 because then it's just homework. So I'm just doing homework help at this point. The -1, Justin was mentioning this. Can we always ignore the alternator in the setup? Yes, because it's going to be irrelevant. But as we plug in, wouldn't that be 2 times n plus 1? So that'd be 2n plus 2 plus 1 is 2n plus 3, right? All over 2n plus 3 factorial. Did you guys start getting a little bit messed up on this guy? But remember, with factorials, aren't we going to have the 2n plus 3 remaining, because that guy doesn't cancel them out, but aren't we also going to have the 2n plus 2 that came before the 2n plus 1 factorial that cancels out? So we have both of those terms. And then here, can't we separate this to be x to the 2n plus 1 times x squared, right? So then we could go ahead and simplify this guy with that guy, and then we would just have an x squared on top. And that's what you're going to be setting less than 1 as you go ahead and continue. Remember, if you get any sort of interval of convergence with an A and with a B, you must test the endpoints by coming back to the beginning, plugging in the endpoints, and doing your convergence divergence test and saying converge, bracket, diverge, parenthesis. And if you have negative infinity to infinity, it's irrelevant. The endpoints are irrelevant because there are no endpoints. Whole section, that first endeavor card, yeah? Okay. Go play with homework. Come back tomorrow with questions. Thanks, guys, for all the work we were able to get done today. Pi Day party. I want to celebrate. Come with something circular, triangular. I don't know about triangular, but that's okay.